Next part of our seminar, we're going to come up with a couple of vocabulary words and some symbols. First off, congruent. Congruent means equal to. It means the same thing as equal to. If I ever have congruent, it means I'm talking about shapes. So that's why when I have shapes here, AB is congruent to CD. Now, what that actually means, though, that means the distance from A to B equals the distance from C to D. Notice when I put a segment above, that's a shape. But when it's not a shape, when it's just the distance, I don't put anything. That just means the distance from A to B. When you look at a shape, you can tell it's congruent if it has tick marks. And you might have like XY here and MN here. And I'll put like 2 tick marks, even if I don't draw. We look at the properties, that tells me they're congruent. 2 tick marks means it's different than like A to C, but it doesn't mean that XY is necessarily bigger because I didn't give you enough information to make that conclusion. Now, if we look at our last problem here, I want to find the value of X if Q is between P and R, like we see that on there. PQ equals 6x plus 20, and QR equals 2 times x plus 6. Rather than having you do this, I did the work for you. You're going to tell me why it's true. Notice we start here with the given. I'm told PQ is congruent to QR. So whenever I know something is true, because I was told it's true, that's going to be given. Then we are going to use these reasons to tell me what we're doing. And we'll do a little bit of shortcut when we write them down to show you first off. First off, from step 1 to step 2, notice I changed that to an equal sign. I can always do that, and that's your first reason on here. Definition of congruence. In this case, they're congruent segments. Then we know PQ from our given is 6x plus 20. Probably should have wrote that down in the beginning too. But when I write, instead of writing PQ, I'm writing 6x plus 20. That is going to be substitution. When you write something instead of something else, we call that substitution. When you look at the reasons, look at, hey, what am I doing from one line to the next line? Well, notice on this one, I distributed that 2 inside. So that's our distributor property. Now on the next line, notice what happened. We just subtracted 2x from both sides. And I even told you right here, subtract 2x from each side. I'm lazy though. I'm not gonna write subtract 2x from both sides. I'm gonna say, hey, I subtracted the same thing from both sides, because we'll call that the subtraction property of equality. Now, if you wrote subtract 2x from each side, you're right. Then, notice I actually did the subtraction. When you actually do the subtraction, that we're going to call simplifying. So we're simplifying. Now, in the next one, it looks like we subtracted 20 from both sides. So, once again, I'm going to call that the subtraction property of equality. You could say subtract 20 from both sides if you want to. And I'll fill that in there. Then we actually did the subtraction, so that's simplifying. Then it looks like I divided both sides by 4. And if we look at our reasons, you have divide each side by 4. And like I said, I'm kind of lazy, so I don't want to write divide each side by 4. I'm just going to write we divided both sides by the same thing. So that's your division property of equality, which I'm just going to abbreviate with divide and equals. And then the last thing we do, we actually took negative 8 divided by 4, so we simplified it again. And there you have it. That's called a proof when you tell me why something is true.